What's up, coders, and welcome back to part 2 of the OSRS shop flipper utility. In this series, our goal is to develop a utility that lets us look at in-game shop prices and buy items for low there, and then flip them for a profit on the Grand Exchange. On the last episode, we developed an API client which got us all the in-game item data as well as the current Grand Exchange pricing data. On this episode, we're going to use that API client we developed to create a SQL Data Warehouse, and then eventually we're going to cross-reference the data in that data warehouse with the OSRS wiki, and we're going to use that to power a front end that we're going to develop in a later episode, and I'm going to give that as a tool for you guys that you can use to flip items for profit. So stick around and I hope you enjoy. First up, I'm going to set up the API client project with automatic versioning. I'm going to do this so when I publish it into a NuGet package, the revision part of the version is always generated based off the date. I do this in case I need to make minor changes and I don't want to have to manually increment the build every single time. So I'm going to pack that into a NuGet package now, and then I'm going to put that newly generated package into my local NuGet repository. I've gone ahead and set up a new project and added a settings.default.json, which I'm going to ignore from Git so I don't commit any connection strings or passwords into Git. The library that I'm using for this data warehouse project is called MIFCore. It's basically a host builder style wrapper over a job scheduling engine called Hangfire. This is a library that I've created myself, so check it out if you need an easy way to make data warehouses and integrations if you like what you see after this video. In a data warehouse, probably one of the most important things you need is a place to store the data. So I'm going to use EFCore to create a DB context. And in that DB context, I'm going to use the model builder to map out the database schema to the API results from that API client we created last episode. I'm going to create a new shadow property called category. Category is one of the parameters required that we pass through to the API client, category being the different types of items. So for example, ammunition or weapons and armor and things of that nature. Now we do this and we make it part of the primary key so we can actually identify what sort of catalog result this is in the database. And this is a shadow property because it actually isn't natively returned by the API itself. What I'm doing is I'm jumping back and forth between the catalog result definition and back to this DB context. And then I'm just using that to figure out different ways to store this information in the database. As you can see here, I'm mapping types to a serialized JSON string because the API doesn't have a strict result set. It's an array of who knows. So I go ahead and I map out the item as well. You can see that I've done owns many and owns one a couple different times here. It's pretty nifty. Owns one basically just merges any sort of child objects into the same table in the database by using underscore and then the child object's property names. Whereas owns many creates a completely new table, and you basically do that to map out one-to-many and one-to-one types. This is what the final DB context basically looks like. I use this version of the DB context and I create the migration so the database is created. So next I have to write the jobs which actually utilize the API clients and write them into the SQL database. The category consumer I later renamed to catalog consumer because its job is to consume the catalog API. After it successfully consumes the catalog API, it will then pass that result as parameters to the item consumer, so the item consumer may use them to download all the items from RuneScape. As part of the MIFCore library, something that you may be familiar with is a startup class. MIFCore library has a startup class as well, where you can register your services for your dependency injection container, but it's also got an additional one called postconfigure, which allows you to inject any services you want, but it occurs after the application has been built and will be ignored when you use the .NET tool EF migrations add to create a new migration. The last thing you want is when you create a new migration, when you're developing a database, is to actually create the database. So this just makes sure that the database is only created when you run the application. And as you can see, I'm also creating a recurring job called categories, which executes the category consumer. This will happen every 24 hours and will basically start the entire data warehouse ingest process. So the category consumer will enqueue categories to consume. So it'll get all the different item categories from that enum, loop through them, and then it will schedule the consume category method as a background job. I rename consume category to consume catalog because it's actually consuming the catalog API. And then consume catalog takes in the item category, executes the API using the item category as a parameter, upserts it into the database using my mad.extensions.efcore project. And that's that part of the data warehouse complete. And this is just me looking at the Hangfire dashboard, which just shows all the different jobs that are running and lets me know if any have failed or not. And here's what the database looks like after running that to the end. Now we're actually going to develop the item consumer, which is where all the functionality that we want actually happens. This is where we actually extract the items and the Grand Exchange prices. The reason that we had to do the catalog consumer first is because the item API requires the item category and the alpha. So the catalog consumer returns a list of alphas for the item category, which we then in turn pass to the item consumer. This consumer is slightly different because it's paginated. So after running a successful consume items, we're gonna enqueue another job calling back onto consume items and increasing the page. And we're going to do that until it returns no more results. And then finally, to link it all together, back in the catalog consumer, we're going to enumerate over the result after we've saved it to the database. And then we've got to schedule the item consumer with the parameters returned from that API. And now we run it. And it all seems to be working. One thing I do notice though, is that the API itself has some sort of rate limiting built into it. So I just have to slow down how fast I'm hitting the API. But as you can see here, all the item data is slowly coming into the database. And that about wraps it up for this video. You can see I'm pretty happy with myself, having a bit of a dance. As always, you should celebrate once you complete a task because it's a job well done. Anyway, thank you for getting to the end of the video and I hope to see you again for part 3.